Hello students, welcome to EPG Pathshala. I am Dr. Ayushi Paliwal from University of Delhi. So students, today we are going to discuss about the module Strength of Composites from the paper Functional Materials. The purpose of this module is to make the students familiar with first, the tensile strength of fiber-based composites, second, the strength of hybrid composites, third, the orientation dependence of the strength, and lastly, the tensile strength of multi-ply laminates. So students, let us start with a basic introduction about this module. Strength is not easy to predict as it depends on not only on the strength of individual phases but also on the mode of failure of the composites. Strengthening effect of the reinforcing phase is also difficult to predict as it depends on its morphology, geometry, and bonding with the parent phase. In order to simplify, particulate reinforcing phase can be taken to have the aspect ratio of 1, and fibers longer than few centimeters can be considered to have aspect ratio of infinity. So everything else falls in between. Tensile strength. One of the simplest model to predict the strength is to interpolate the stress-strain plots for fiber and the matrix. So under isostress condition, stress can be considered to be distributed as sigma C is equal to sigma F mu F plus sigma m prime multiplied by 1 minus nu f, where sigma f is equal to E f epsilon and sigma m prime is equal to E m epsilon are the stress levels in the fiber and the matrix respectively. Here, epsilon is being the overall composite strain. So these are the figures showing the schematic for the stress-strain plots. The left side figure shows the schematic of the stress-strain plots for a matrix, a fiber, and the two composites, that is composite 1 have nu f1 and composite 2 having nu f2 to be greater than nu f1. The right side figure shows the schematic of the strength of composite with variation in the fiber content. So students, continuing our discussion on tensile strength, when the fraction of fiber is very small, the load is effectively carried by composite and hence for small fractions of fiber, strength of composite can be given by sigma C is equal to sigma mu multiplied by 1 minus mu f, where sigma mu is the load carrying capacity of the matrix when not mixed with the fiber, that is UTS of the matrix. From these two relations, we can find a critical value of fiber below which the strength of the composite is dominated by matrix and above which the strength is controlled by fiber. This critical volume is given by V critical is equal to sigma mu minus sigma m prime divided by sigma f minus sigma m prime. Tensile strength of hybrid composites. In a hybrid composite, if one of the fiber of high strain to failure ratio is added along with the fiber with low strain to failure ratio, the overall strength is reduced. Once the fiber with low strain to failure fails, fibers with higher strain to failure cannot carry rest of the load and the overall composite fails. Strength of such hybrid is given by the following expression, that is sigma C is equal to sigma Lu VL plus epsilon Lu EH VH, where sigma Lu, epsilon Lu are the strengths and the failure strain of the fiber with low strain to failure respectively, and VL is the volume fraction, and EH and VH are the modulus and volume fraction of the fiber with higher strain to failure respectively. Tensile strength of hybrid composites. As described earlier, hybrid composites are the composites where more than one fiber or any kind of structures are included. Adding more than one kind of fiber is advantageous, but it also carries some limitations with it. If one of the fibers of low strain to failure is added along with the fibers with high strain to failure, the overall strength is reduced. Hence, the fiber with low strain to failure fails. Fibers with higher strain to failure cannot carry the rest of the load and the overall composite fails. Strength of such hybrid is given by sigma C is equal to sigma Lu multiplied by VL plus epsilon Lu multiplied by EH VH, where sigma Lu, epsilon Lu are the strength and failure strain of the fiber with low strain to failure, and VL is the volume fraction, and EH and VH are the modulus and the volume fraction of the fiber with high strain to failure. However, when the proportion of fibers with high strain to failure keeps increasing, then it reaches a point where it can carry the load even if the fibers with low strain to failure fail. This is given by sigma C is equal to sigma HU multiplied by VH, where sigma HU is the strength of the fiber with high strain to failure and VH is its volume fraction. So, the critical volume fraction for transition can be given by VH must be greater than equal to sigma Lu divided by sigma Hu plus sigma Lu minus epsilon Lu EH. So students, this figure shows the variation of strength of hybrid composite with the change in volume of different fibers. Now students, let us discuss the tensile strength having the dependence on orientation. Strength of composites with the fibers oriented in a particular direction, they will be very anisotropic. It will be very high along the fibers and very low perpendicular to it. If the strength of the composite parallel to the fibers, perpendicular to the fibers, and in shear parallel to the fibers is given by sigma P, sigma T and tau C. Then the failure of the composite can be classified into three different modes, which will change with the orientation of the applied stress. Now we will discuss the orientation dependence on the tensile strength. We have already discussed that the failure of the composite can be classified as: first, the failure controlled by tensile fracture of the fiber, that is sigma theta is equal to sigma c sec square theta. Second, the failure controlled by shear failure along the fibers, which is given by sigma theta equal to 2 tau c cosec 2 theta. Third is the failure normal to the fibers, which is given by sigma theta equal to sigma t cosec square theta. This figure shows the orientation dependence of the strength for carbon fiber or epoxy resin composite. As you can see, Here all three kinds of failures have been shown. Multi-ply laminates, or we will be discussing here the tensile strength of multi-ply laminates, a simplified model to predict the strength of multi-ply laminates uses the efficiency factor similar to that used for estimating the elastic modulus. Here eta is equal to the summation of an cos theta to the power of 4, where an is the proportion of fibers at an angle theta. It can be seen that eta is equal to 1 for unidirectional laminate, while for 0-90 cross-piled laminate, eta is equal to 0.5. Using this efficiency factor, strength of the multi-ply composite is given by sigma c is equal to eta sigma f bar plus sigma m prime multiplied by 1 minus Vf or mu f. So students, let us summarize what we have learned in this module. Strength of fiber-based composite is found to be dependent on the variation in fiber content. Tensile strength of hybrid composites is discussed, indicating its dependence with the change in the volume fraction of different fibers. Strength of composites with the fibers oriented in a particular direction can be expected to be very anisotropic. It is expected that it will be very high in the direction along which the fibers are oriented and very low perpendicular to it. A simplified model has been proposed to predict the strength of multi-ply laminates, which uses the efficiency factor similar to that used for estimating the elastic modulus. Thank you.